All right, so what's the deal with copper having a smaller specific heat than styrofoam? Okay, so metals conduct heat easier than most other things, but why is it that metals conduct heat better? What is it about a metal that allows it to conduct heat more effectively than styrofoam in this case? How is heat usually conducted? Or let me rephrase that. How is heat conducted? If something is going to warm you or cool you, what needs to happen?
It's the
How?
atoms need to move.
More atoms need to move, or they need to do what? Line up. They need to touch, right? So if something is cooling you off, something is touching you. Are you okay with me saying that? It's obvious if I put an ice cube in your hand that you're being cooled off by this ice cube that's touching my hand. But what if I just open up the freezer and stick my face in front of it? Am I being cooled off by something touching me?
Yes.
Yeah? Air molecules are touching you, right? So something has to make physical contact with you. So that's how heat's transferred. Physical contact between substances. So now what you need to think about is things need to physically connect to each other, touch each other, for them to transfer their energy. So now think about this question.
Because the metal doesn't move, the styrofoam isn't necessarily.
No, not about moving. It's a density issue, right? The closer two things are to each other, the more likely they're going to give off heat to each other. Does that make sense? If you're like on Mount Hood and it's November and it's a really beautiful day and you're up there for like 3 or 4 hours with a group of people and then all of a sudden snow comes in and you can't leave, do you huddle? Do you go into a cave and just mull around? Everybody huddles together real close, right? So they all share their body heat. So the situation is the copper atoms, they're really close together, so they can transfer their heat from one atom to the next very simply. What do you know about the styrofoam's atoms? The molecules must be more spread apart because its density is, I don't know what, 100th that of copper, maybe even less than that. So it's about touching, right? These windows here are way more effective than the window that's in my bathroom at my house. It's a single pane piece of glass. Why is that a bad window?
It's all very easy. Strong strands.
Right? So there's cold air on the outside. That cold air touches the window. Now the window's cold, and the air on the inside of the house that's warm touches the inside part of the window, and heat can transfer from the warm inside part of the window to the cold outside part of the window. So why is this a better window?
Because there's space in between it.
And what's in between it?
Gel.
A gas, right? A gas. So what's the density of a gas? Copper's high density, styrofoam low density, gas really, really low density, right? So they pump these things up with like an argon gas or something like that, maybe a couple other things to reduce the amount of heat transfer out via light. And so those gas particles on the outside that are colder than the gas particles on the inside, they can't come in contact with the same piece of material. So what has to happen is the cold particles on the outside have to cool this glass, then that glass has to cool the gas inside, then that gas has to move over and cool the glasses on this side, and then that has to cool the gases on the other side. So it's much more difficult for the heat transfer to occur because I put a spacer with no density in there. So if you want to be warm, what do? Wrap a blanket up tightly?
Around you, I mean, like,
Is
as close and touching as possible.
is that helpful?
No. 'Cause it's-
What would you really want to do?
You just wanna-
You'd want to have a big blanket that was like all loose and just against you, right? How about this? Homeless people have been known to take newspaper and shove it into their clothing. Why? What's the density of crumpled up newspaper? Low or high? low. So what's the fact? How well will the heat be transferred through this pocket of newspaper? Think about the insulation in your house. Is that very dense? No. So what a person is doing when they shove newspaper into their coat is the same thing that you're doing when you layer an insulator in between the drywall and the exterior of the house. You're putting a substance in there that doesn't transfer heat very well because its density is super low. What would be the best is if we could evacuate these windows out and have no gas in them at all. But why is that not a possibility? The glass would break, right? Because there's 14.7 psi on both sides of the window pushing in. There'd need to be something pushing out, and if there isn't, then those pieces of glass would collapse on each other. If we could make some ridiculously strong glass and then suck all the air out in between them and the glass wouldn't break, that window would be like 1,000 times better at insulation. So, something to work on if you're interested. People have discussed making metals in a particular configuration that allows them to be clear. So if you could make something like clear aluminum or something like that, then zillionaire. Okay, let's fill this table in. So 41, what element is that? Niobium. NB, right? And so then the electrons are 41, and then the mass is 107. That sound good? No? About 97. That's better. So copper. So what element is copper? Element 29. So it's got 29 protons and electrons. And so that would be 34 for this one's number of neutrons. And then what's 18? Well, I got 18 and 35, so what's that leave me with? 17? And so what element is that? Chlorine. And then I've got francium, so that's element number what? 87 and 87 and francium. And so what is that? 225. Okay, so now we're going to put the electron configurations up for aluminum. So it's 1s2, 2s2, 2p6, 3s2, 3p1. And bromine. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. And copper, 1s2, calcium, 2s2, 2p6, 3s2, 3p6, 4s2. And how do you quickly know that phosphorus is more electronegative than germanium? Easiest way, just like a quick blah, phosphorus is closer to fluorine. Fluorine's the most electronegative one. Who's ever closer to the more electronegative one is automatically the one that's going to be more electronegative. So that's the quick, down and dirty, easy way.
So you just said it has more electrons.
No, that doesn't answer the question. Having more electrons does not mean that you're more electronegative, because fluorine has the least number of electrons in the halogen column, and it's the most electronegative. So fluorine, closest one, whoever's closer to fluorine, that's the one that's more electronegative. Hund's rule. Why does Hund say you need to fill up fill up each orbital before doubling up?
Because they don't want to be by each other.
How about that? They don't like each other. They're all negatively charged, so until you have to put them together. How about this graphite and diamond one?
It's the structure of
The structure for graphite is one carbon atom bonded to 3 other carbon atoms. The structure for diamond is one carbon atom bonded to 4 other And the more important part of that is when I go to 4, my structure becomes 3-dimensional as opposed to 2-dimensional in graphite. So it's really a 2D to 3D structure thing. It's how many times I can be connected to the same thing. Ozone is a deadly gas. Why do organisms want it on the planet?
Keeps the sun's radiation.
Block UV. Why is blockage of UV important? A lot of skin cancer, right? What's particular about UV? Its length makes it have a particular amount of energy. It's the first form of radiation that's strong enough to break a chemical bond. UV, ultraviolet, is the exact same type of radiation as violet colored light. Are you afraid of purple lights? You shouldn't be. Why not? It has a teeny bit less energy than ultraviolet, and that teeny bit difference makes it so purple light cannot hit you and break your bonds, where ultraviolet light will hit you and can break chemical bonds. Anything that's stronger than ultraviolet light can break a chemical bond. And with cancer, what are you worried about? You're worried about DNA splitting, and right as it's splitting, a bond goes in and breaks, and something goes in there that's not supposed to go in there. That's the problem. So if something can't break a bond, you can't what? Can't get cancer, right? You can't get cancer if something can't break a bond, because the bond has to be broken. And purple light or red light or microwave light, none of those things can actually do that. Okay.